Hello. In this video, this is what I'm calling Unit Circle Part 2. In this video I'm going to try to describe a little bit more about terminal points. I'm trying to describe about reference numbers, and we're also going to come up with some more special angles or special lengths for radians in the unit circle. Okay, now we've talked about terminal points before. For example, I have a terminal point on the unit circle in the second quadrant, negative square root of 2 over 2, square root of 2 over 2. This is a terminal point. You can show that if you put it in this equation, you do get a true statement. Now, you can go around the circle more than once. You know that if you go around in a counterclockwise manner, and go all the way around, you've gone 2 pi. If you kept on going, you've gone 2 pi. If we go around again, this will be 3 pi. So the terminal point of 3 pi would still be negative 1, 0, the same as it is for pi. If I kept on going around again, I'd get to 4 pi. And if I kept on going around even one more time, I'd get to 6 pi. You can keep going around like that. You can also go in a negative manner. If you go in a clockwise manner from the positive x-axis, that's what we call going negative. So we're saying that t is a negative number if t is the length along the unit circle that we're traveling. If I went to, say, negative 3 pi, well, if I go around negative, there's negative pi, negative 2 pi, negative 3 pi, and back to the terminal point of negative 1, 0 again. Now that brings up the topic of reference numbers. The official definition of a reference number that's found in your textbook is written on the board. It says let t be a real number. And notice that we say that t can be any real number. It can be positive, negative, special angle, or not. The reference number, I underline reference number because I'm defining that, the reference number t prime or t bar associated with t is the shortest distance along the unit circle between the terminal point determined by t and the x-axis. Okay, so to get hold of that, we need to start thinking about some special angles here. Now, in the last video I talked about going all the way around and get to 2 pi, and then we broke it up in the force, and we found out that if we go from here to here, that's pi over 2, and if we kept on going, that's another half circle. That's half circle, we get to pi, another quarter gets us 3 pi over 2, and that gets us back to 2 pi. That's going around in halves. Then, if you go half of this distance, well, half of this distance would be half of pi over 2, which is pi over 4. So now what we're going to do is we're going to go around with the denominator of 4. So if I go from 0 to pi over 4, 2 pi over 4, 2 pi over 4 is pi over 2. This would be 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, reduces down to 3 halves. This would be 7 pi over 4, and then 8 pi over 4. And you can keep going if you wanted to. And also, so now we can talk about the reference number for this value, or for this terminal point, okay? We know that the distance from here to here, going on the unit circle, is 3 pi over 4 units. We say it has a reference number of pi over 4 because the reference number is the shortest distance from the x-axis. It could be the positive x-axis or the negative x-axis. The shortest distance along the unit circle. Along the unit circle, the shortest distance to this terminal point would be this distance here. And this distance here is going to be pi over 4 units. So that's what we mean by a reference number. Okay? Now, all right. So we've gone around in fourths. Now let's go around in thirds. Okay? If I go around in thirds, well, a third of the way is going to be here. We're going to say that's pi over 3. If I go another third, that's going to be 2 pi over 3. Another third would be 3 pi over 3. 3 pi over 3 is pi. Another third would put me here at 4 pi over 3. Another third put me here at 5 pi over 3. And then 6 pi over 3 for my last third. Okay, so what I'm getting to here is some special angles along the unit circle. And if you're ever going to, and you will eventually have to create a unit circle from memory, and I want this to make sense to you, so this is part of the way we create it. All right, there's more to it. We need to get the coordinates of all these points in here first. Now, so we've gone around in units of pi. We've gone around in units of pi over 2 with the denominator 2. We've gone around with the denominator 4, gone around with the denominator 3. We're still missing some lines here. Now, so from here to here, that's going to be 1/6 or pi over 6. So we're going to go around now with the denominator 6. And notice that's also going to hit the denominators of 3. Okay, so from here to here, we're going to say that's pi over 6 units. If I go another pi over 6 units, that's 2 pi over 6. Well, 2 pi over 6 is pi over 3. 3 pi over 6. 3 pi over 6 is pi over 2. 4 pi over 6. Well, once again, that reduces. This is going to be 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6, and then finally 12 pi over 6. So now we've got all our special links, the special ones, not all of them, but just the special ones, defined on our unit circle. And the way we did it, one more time, I want y'all to be very familiar, very comfortable with this. The way I do it is I start with pi. Or actually 2 pi. You go all the way around, that's 2 pi. Half of that is pi. Half of that is pi over 2. So you go around in halves. So you know from here to here is pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Then I go around in half of that. Half of pi over 2 is pi over 4. So I'm going to go around in pi over 4. And if you look at it, that's really 45 degrees. But pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. And then what I do is I go around in 6 because that'll get all of them for me. If I go around in 6, from here to here is pi over 6, 2 pi over 6, which reduces down to pi over 3, 3 pi over 6 reduces to pi over 2, 4 pi over 6 reduces to 2 pi over 3, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6 reduces to 4 pi over 3, 9 pi over 6 reduces to 3 pi over 2, 10 pi over 6, 10 pi over 6 reduces to 5 pi over 3, so there's 10 pi over 6, 11 pi over 6, 12 pi over 6. Okay, and you can get just about all of them if you go around in 6. You can get all of them plus a few that you don't need if you go around in 12s, because if you look at the denominators that you have here, the denominators are 2, 3, 4, and 6. The least common denominator between 2, 3, 4, and 6 is 12. So if we go around in 12s, we get all our special angles, but we also get a few that we don't need. So this is the way I do it. I go around in 4s and 6s. Okay? All right, so hopefully that'll help clear up some things about reference numbers, terminal points, and the special angles. Now, I also want you to notice that if we start thinking about degrees, remember what we're saying is from here to here is pi over 6. That's how far this arc of the circle is. From here to here is pi over 6. And it's also pi over 6 radians. Now, if you stop and think about it, in another video I mentioned that pi radians is equal to 180 degrees. If you want to convert, if you have pi over 6 radians, and you want to convert, what you do is you multiply by your conversion factor. We know that pi radians is equal to 180 degrees. You can turn that into a conversion factor. If I divide both sides of this equation by pi, I get 1 is equal to 180 degrees over pi radians. Or if I was to divide both sides of this equation by 180 degrees, I'd get pi radians over 180 degrees is equal to 1. And you know that you can multiply anything you want by 1, you don't change its value a lick. So, I'm going to multiply pi over 6 radians by 180 degrees and over pi radians. And 180 degrees over pi radians is simply 1. Now if you look at this, the pi's cancel out. 6 will go into 18, 6 will go into 8 3 times. So you get 30 degrees. Okay, so in other words, from here to here, this angle is 30 degrees. The angle to pi over 4 would be 45 degrees. The angle to pi over 3 would be 60 degrees. And the angle to pi over 2 is 90 degrees. Okay, so there's our acute angles, and you can keep on going with that, and we will. But for right now, this is what I want you to know. Okay? Hopefully we know what reference numbers are, terminal points, and we've come up with the units of length of the unit circle for the special angles and also the angles that those translate into. Thank you. Go do some math.